Good, we'll start now. Surface chemistry. Take down. The major concepts coming under surface chemistry are adsorption, sorption, desorption, then we'll be discussing about true solution, colloids, suspension. Under adsorption, we'll be discussing physical adsorption. Physical adsorption, that is also called physisorption. Physisorption. Physical adsorption, that is physisorption. Then we have chemical adsorption, that is called chemisorption. Physisorption, chemisorption. Then we should know something about the adsorption isotherm. Adsorption isotherm. Then adsorption isobar. So we are discussing now the overview of this subject, that is surface chemistry. Let me explain one by one later. Just to note down the topic 3 of the top. This is surface chemistry. Then we need to explain about applications of adsorption. In the case of application of adsorption, we'll be discussing an extensively very important topic called catalysis. Catalysis. And then we need to discuss on the factors influencing adsorption. Factors influencing adsorption. Then, regarding colloids, here we have some subtopics. We will discuss about lyophilic and the lyophilic phobic colloids. leophobic, leophilic and leophobic colloids, and we'll be explaining about macromolecular substances also, colloids, macromolecular colloids. Then we will discuss the associated colloids and application of colloids. Application of colloids. Then we'll be explaining about the properties of colloids. In fact, colloidal chemistry is a separate topic. Anyway, this is brought under surface chemistry. So this is the overview about this topic. Let me explain one by one. Now, adsorption means it is a superficial phenomenon. Adsorption means it is a superficial phenomenon. Take down surface level phenomenon or superficial. Let me ask you some simple question. See, there is a coloring of some article. This can be done by two ways. One is by painting, another by dyeing. So in fact, painting is a surface level covering or coloring. So it is a superficial. Okay, it is the superficial coloring. Whereas a dyeing it is an interfacial covering. Okay, so if you have some table or chair or anything, you will apply paint on the surface only. Okay, so on the surface, and the painted material is adsorbed. So adsorbed means the surface level only, that is this one, adsorbed, ADS, adsorbed. Whereas absorption means it goes inside the material. For instance, you have got some plastic component or plastic bucket where it is colored. So the entire plastic is colored, dyed. So hair dyeing is an interfacial phenomenon. It penetrates into the substrate, whereas this coloring takes place on the surface only. I hope now you should be able to understand. Okay, right. So, like in the case of solution, I have already explained about solution. Solution is nothing but a mixture of solute and solvent that you know very well. Okay, solution. So it consists of two parts. One is solute, another is solvent. Okay, now this solute is the smaller portion, whereas this is the major portion. Similarly, you have in adsorption solution also, where the adsorbate is the adsorbent. So adsorbent is the surface level phenomenon, surface or substrate, that is called adsorbent. That is the equivalent term. And here adsorbate is the absorbing material on the adsorbent. Okay, so that is called adsorbate. Okay, adsorbate. And even in the case of, I was talking about this colloidal solution, how this colloid occurs, it is based on the solute particle size. So the solution can be actually classified based on the particle size of the solute. Here you have true solution, and here suspension. In between that you have colloids. Okay, so here the solute is, the size of solute is very less, very less, whereas it is somewhat bigger, and this is moderate in between that in terms of microns. Okay, around a nanometer we can say. So it is in between, the solute particle size lies between suspension and the true solution. For example, sodium chloride solution, you cannot see, okay, the solute particle once it's dissolved, whereas suspension you can see the solute particle, that is suspended particle. So that is the equivalent term. Suspended particle can be observed with the naked eye, whereas in the case of colloids it can be viewed under microscope. Okay, for instance, ink, particularly blood, these are all, even paint substances. Paint is suspension, and there are some colloids also, colloidal dispersion, where these dispersed particles can be seen with the help of microscope. Okay, right. So I hope now you should be able to divide this solution into three types: true solution, colloids, suspension. So this classification is based on the particle size of the solute. So true solution, where the particle size is the least, suspension bigger, whereas in the case of colloids it is in between. Okay, you please go through, and if there is any doubt you please ask me. Let me pause for some time, a few minutes. Please go through it. If there is any doubt you can ask me. I am now discussing only the overview about the subject, about this topic. Then, so I hope now you should be able to understand the adsorption. For example, let me have ink that is adsorbed over the chalk piece. I have got the chalk piece like this, and there will be some ink. Okay, ink is superficially trapped. Okay, so this phenomenon is called adsorption. So force between when the force between adsorbent and adsorbate, what do you mean by adsorbent? That is a substrate over which adsorbate or diffused over. Okay, diffused. So adsorbate and adsorbent, when there is an interaction between this adsorbent and adsorbate of, or the bond or the link between these two, or of physical nature, that is van der Waals force, then it's called physisorption. If the bond between them is chemical nature, then it is chemisorption. Okay. But the physically adsorbed particles can be easily retrieved. It can be easily removed. But the chemically bound adsorbed particles are very difficult to be removed. Then, and adsorption isotherm means we will be studying some characteristics based on the rate of adsorption and also at constant temperature. So we will be studying the characteristics of adsorption at constant temperature. So isotherm. And we will be able to get some curve at constant pressure also. So this is adsorption isobar. And we will discuss the applications of adsorption in this topic where catalysis is very, very important. Catalyst is nothing but catalyst is nothing but an activator. It can either activate or deactivate also. When it deactivates the reaction, then it's called inhibitor. Okay, inhibitor. I'll take 10 more minutes. Please bear with me. Let me cover the overview of this topic only. I'm not going in deep. Now, catalysis, I was explaining about catalysis. This catalysis is a very important one to be studied. Catalysis. That is, lysis means cleavage of bond, chemical bond. Using catalyst, when we are able to cleave a bond, it's called catalysis. This catalysis can be of two types: homogeneous catalysis, heterogeneous catalysis. Take down homogeneous catalysis, heterogeneous catalysis, where probably that is you would have heard some catalyst activating some reaction. So in that case, probably when the physical state of catalyst and the reactants are same, all of them are gases, means it is homogeneous. But if the catalyst is distinct, physically distinct, suppose if it is solid or powder, and the reacting substances, that is reactants or gases, then it can be called heterogeneous catalysis. But heterogeneous catalysis, there is some advantage. We can easily remove the catalyst. What is the role of catalyst? It just activates the reaction, enhances the reaction, and it should be retrieved also. And catalyst is a substance that should be added in small quantity. So these are all the characteristics of catalyst. And this catalyst can also be classified as promoter and inhibitor. Okay, another type of classification. This is classification A and this is classification B. So when it increases the rate of the reaction, it is called accelerator. It's called not promoter, accelerator. Then inhibitor, when it blocks, when it retards the reaction, it can be called a retarder also. So inhibitor. It decelerates the rate of the reaction. Okay. And there are some substances which activates further and they can be called promoters. Okay. Promoters. Okay. Then we will be discussing about the activity of catalyst also. As a separate topic. Activity. Okay, activity of catalysts. Then there are some catalysts which are very, very shape selective. Okay, so we need to study that one also. Shape selective. Shape selective catalysis. And we'll be studying about biocatalysis also, that is called enzymes. Okay, so these are all the various topics under the catalysis. Then I was discussing about the factors affecting the adsorption, factors affecting or factors influencing adsorption. Okay, take down. And there are some features about this. Let us discuss that one. What are the factors affecting what? The adsorption. So temperature is a very important one. Then pressure that affects. Then surface area of the catalyst, that is also very important. Surface area. Then the nature of the gas that is absorbed. Okay, and the nature of adsorbent. Adsorbent means absorbing surface. Okay, nature of adsorbent. Okay, so when we talk about the colloids, I was discussing about colloids somewhere here. Yeah, colloids. So these colloids, see colloids, you know something about the desorption. Desorption means the process of removing the adsorbed material from the adsorbent, absorb it from the adsorbent. Okay, that is called desorption. Then true solution I already discussed. Then colloid. Leo means fat. Okay, so fat philic, oil philic, or fat philic, fat loving. Okay, so actually this is almost equal to hydrophobic. That is, if it is oil loving means definitely it will be water hating, just opposite. So philic means to attract. So it is oil soluble colloids. You can say oil soluble colloids. Then oil insoluble colloids. Oil insoluble colloids. Oil insoluble colloids means which is nothing but hydrophilic, is it not? Just opposite term. Hydrophilic. Then is a macro, the size is macromolecule, and we will be discussing about associate colloids and application of colloids, then the properties of colloids. With regard to properties of colloids, there are some important aspects to be discussed. Here we have optical effect, that is called Tyndall effect. You would have heard about this in your 10th standard also, the diffusion of light. Okay, so this is called Tyndall effect. So because of its size of the dispersed or the colloidal dispersion, dispersed particles, the scattering of light takes place. And this is the optical property of colloid. And this one is called mechanical property of colloid, that is known as Brownian movement. So the zigzag movement of colloidal particles, that is known as Brownian movement. So these colloidal particles will be automatically moving like this, but it won't be curving. Here it can move at random, but it adopts linear motion only. Okay, zigzag motion. And then the electric property, so that is called electrophoresis. Okay, so we will discuss that aspect also. Electrophoresis. Okay, then we'll discuss a very important topic under colloid, that is coagulation. Okay, coagulation. So I hope now I have given the entire overview about the surface chemistry. So under some surface chemistry, we'll be discussing adsorption, and these are all the various aspects about adsorption, then sorption, then desorption, then true solution, Under colloids, we'll be discussing lyophilic, lyophobic, macromolecular, etc. Then we will discuss as a separate topic under suspension. And as I already mentioned, see that is we should know something about the adsorption and absorption. There are some differences between adsorption and absorption. So we will get into all these details in our next class. Okay. And here catalysis, and we will once again illustrate with various examples, and where from you will be able to understand the importance of a catalysis. There is a separate topic called the industrial significance of catalysis, industrial catalysis. Okay, so these are the basic aspects you should know about surface chemistry. Okay, it may be theoretical, but it's quite interesting. Okay, even the nowadays, I mean, the present corona issues can be discussed based on the surface chemistry.